We have discussed the convergent sequence, and if we have a convergent sequence, then the limit of that sequence will be unique. ये दोनों बातें, what do I mean by a convergent sequence? और अगर convergent sequence कोई हमारे पास है तो उसकी लिमिट जो है वो यूनिक होगी, हमने डिस्कस की है. अब लास्ट मॉड्यूल में आई हैव यूज्ड द वर्ड कि इफ अ सीक्वेंस इज नॉट कन्वर्जेंट, व्हाट डज इट मीन? इट मीन्स वी विल से दैट द सीक्वेंस इज डाइवर्जेंट. और मैंने ये कहा था कि इस टर्म को आई एम गोइंग टू एक्सप्लेन इन द नेक्स्ट मॉड्यूल. सो टुडे वी आर गोइंग टू डिस्कस द डाइवर्जेंट सीक्वेंसेस व्हिच डाइवर्जेस टू the plus infinity and minus infinity. These two particular numbers I have included in the set of real numbers, and if you remember, I call the set of real numbers including these two numbers, which is plus infinity and minus infinity, as the extended real number system. So we are going to discuss what do I mean by a divergent sequence and the sequences which are divergent to plus infinity and minus infinity. So in today's module, the sequence is divergent to plus infinity and minus infinity. Or the important thing is कि यार ये सिर्फ sequences जो divergent होंगे वो हमेशा क्या plus infinity को या minus infinity को diverge करेंगे? नहीं, ऐसी कोई बात नहीं है. आज के मॉड्यूल में आपको मैं एक ऐसी एग्जांपल दूंगा जो कि सीक्वेंस डाइवर्जेंट होगा, लेकिन ना वो अप्रोच कर रहा होगा प्लस इन्फिनिटी की तरफ, ना वो अप्रोच कर रहा होगा माइनस इन्फिनिटी की तरफ. तो लेट्स सी कि व्हाट डू आई मीन बाय द डाइवर्जेंट सीक्वेंस, एंड इन पर्टिकुलरली द डाइवर्जेंट सीक्वेंस व्हिच डाइवर्जेस टू प्लस इन्फिनिटी एंड माइनस इन्फिनिटी. A sequence Sn is said to be divergent to plus infinity if for any real number A, we are able to find out the sequence terms, how large it is, I don't care, such that the Sn, the sequence terms, are greater than that real number. कोई भी real number आप लें, you will always be able to find out the terms of the sequence which are greater than that real number, and it is true for all real numbers. Of course, then I will say that the sequence is divergent and the sequence is divergent to plus infinity. Similarly, if for all real numbers I will be able to find the terms of the sequences such that the sequence terms are less than all the real numbers, then I will say that the sequence is divergent and it is divergent to minus infinity. For all real numbers, it's very important कि दोनों definitions में है. For all real numbers A के लिए हम ये बात जो है वो कर रहे हैं. So let's discuss an example. In this example, we have a sequence whose nth term is defined by n divided by 2 plus 1 over n. Of course, its terms n starts from 1 to infinity, because 0 अगर include करें तो 1 over 0 ये आपको पता है infinity है. This sequence diverges to infinity. Now recall the definition जो भी हमने discuss की है कि for all real numbers, A belongs to real numbers, we have to find out some integer, natural number, n such that Sn is greater than or equal to, greater than in fact for all real numbers A. And n जो है ये हमने find out करना है कि n greater than equal अगर इस number से हो तो this is true for all real numbers A belongs to R. Since A is any real number, यहाँ पे यही लिखा हुआ है A is any real number, then n over 2 plus 1 over n जो कि nth term है sequence की मेरे is greater than for all real number if n is greater than 2a. Now if a is real number, then 2a will be a real number. Now it's a property of real numbers that every real number is between two consecutive integers. It means a के लिए मुझे n और n plus 1 consecutive integers जो है वो मिलेंगे. It is true for all real numbers. कोई real number लें, that will be between two integers, consecutive integers. So I can have a natural number or some integer which is greater than that 2a. अब अगर n ऐसा हो जो कि 2a से greater हो, तो मैं देखना चाहता हूं ये valid inequality है कि नहीं. तो n greater than 2 है, तो मैं 2a divided by 2 plus 1 over 2a इसको मैं solve करूंगा, और ये of course greater than a जो है वो आएगी, because 2 से cancel हो गया. a plus 1 over 2a is greater than a. a whatever कोई number a हो, 1 over 2a, और ये n से greater 2a है, और n जो है ये positive कोई integer है. So I will have this inequality holds. So for all real numbers, I will be able to find out an integer n such that this inequality holds. In other words, I have proved that the limit of n approaches to infinity, n by 2 plus 1 over n equals infinity. Let's discuss another example. Now this is the sequence n minus n square, and it diverges to minus infinity. Why? Because if we take any real number, then minus n square plus n, जिसको मैं minus n into n minus 1 लिख सकता हूं, it is less than a if my integer n is greater than 1 plus square root of mod of a. I leave this as a small exercise to you कि for all n which satisfy this inequality implies the sequence Sn less than a for any real number a. ठीक है? So given any real number a, आप इस expression को evaluate करें और उससे बड़ा कोई integer ले लें, तो ये inequality जो है Sn less than a will be satisfied. Since a is any real number, it means that this sequence is divergent and it diverges to minus infinity, जो कि यहाँ पे लिखा हुआ है. So therefore we write limit n approaches to infinity minus n square plus n equals minus infinity, and we say that the sequence is divergent. अब क्या यही दो possibilities हैं कि अगर कोई divergent sequence होगा और वो diverge करेगा either to plus infinity or minus infinity? It's not the case. There are some sequences in which the sequence is divergent, but it is neither divergent to plus infinity or minus infinity. Such a sequence is known as the oscillatory sequence. इसका मतलब ये होता है कि ये oscillate कर रहा है इसकी terms. We cannot restrict the terms of the sequence after certain number n, capital N जो हम कह रहे हैं, उसको restrict नहीं किया जा सकता into small intervals जो कि lead करें एक fixed real number L की तरफ. This is the example. Sequence आपका define है -1 raised to power n cube. This sequence diverges but not to minus infinity and plus infinity because इसकी terms जो हैं alternate terms हैं, plus minus वाली terms आ रही हैं और ये oscillate कर रहा है sequence. Such a sequence is known as the oscillatory sequence. So we have defined the term divergent in today's module. A sequence is said to be divergent if it diverges towards plus infinity, if it diverges towards minus infinity, or if it oscillates. That's it.